Okay, let's get started. Alright, so now this time I'm gonna focus on a puzzle room, which is the first room where you get like an upgrade, I guess, maybe. But anyway, it's a room where you get an upgrade where you can sort of activate these puzzle mechanics. I can show you here if we open up the editor. So here is this room, and it's not complete yet, as you can probably tell. But the idea is you enter from below here. Now this door is locked and this door is open from the start because it's connected with this machine, and this machine is initially on, so that means that the door will also open up. And so you go in here, and then the only way you can go is in here, and so you go over here, and then there is an area activator over here which activates this one, so it turns this off, which also then closes the door. So you go over here, this gets closed, then you can pick up this item here, and you can then, the only thing you can do is basically learn how to use this, and then you activate this toggle, which opens up this door, and then you can jump up here. Now what I'm thinking about here is having, like, you know, a classic sort of, these things are, they can sort of retract or whatever, they can sort of disappear, you could say. So at one point they are solid, and when they get activated they are not solid anymore, so you fall through because they kind of retract into the wall. And so we have I'm trying to set up a little mechanism here. Now these things are like outside of the map, so you can't really, you're not able to see them or interact with them. They're just here to set up this logic here. And so anyway, so yeah, the idea is that these two are sort of on the same cycle. They will be solid and not solid at the same time, but these ones are alternating. So first you jump onto this, then when the animation starts you have to jump over here to land on these guys, and then the same thing, and then you're up here. So that's the idea. And in order to accomplish this, I needed to add a new type of I mean, I either needed to sort of change an existing one or add a new one. So I added a new type of device, which is kind of like a delay signal device. And so what we have here is two delay signals. Now this guy is like a timed toggle, which means when it gets activated, it's turned on for, like, you know, some amount of time, and then it gets deactivated. And then you have to manually sort of trigger it again, or it has to be triggered again to turn on. But the way I set it up here is that this is linked to these two and these two. So this is turned on, let's say, when you enter this area, because when you enter this area, this gets triggered, which triggers this. I could have just triggered this immediately, but I was playing around with the setup here. But anyway, so essentially this gets triggered, which extends these two, I believe, or maybe it retracts, I forget, but it toggles the state here anyway. Then it also sends into these two, so which means that this is on for like 3 seconds here. These two are then getting a signal. Well, the idea is that these two gets the signal, but they don't turn on for 3 seconds, so they wait. This one waits for 3 seconds before it sends its signal across, and this one is connected to these two, so they will be delayed essentially by 3 seconds. So these two will be immediately affected, by this signal, and this one is like immediately, or I mean, this one is delayed by 3 seconds essentially then. And also in order for, so now we get the alternating thing, but also in order for this machinery to keep going, because if we end there, then this is just gonna turn off and that's it. But what it is, I create another delay which feeds in back into this one. So now we have like an echo that goes back, but this one has a delay of 6 seconds. And so the idea is then that, well, double the time. So one cycle is 6 seconds, because 3 seconds is half a cycle. That's how long each one of these are extended. And so 6 seconds is the whole thing. And then after 6 seconds, this gets turned on again for 3 seconds. Yeah, this gets turned on, and then this gets turned on for 3 seconds. And so, and then the cycle repeats. So, yeah, the idea is to create these delay devices that can receive signals which are delayed for a certain amount of time, which I haven't implemented yet, which I'm currently implementing right now. So this whole system is like you build this kind of system in order to build this kind of, puzzle room or whatever. So yeah, that's the idea behind that. So now I have to implement these guys, and it's kind of interesting because what if you have like so we have like an on and off state. We have the properties, which are which entities are they gonna activate, and how much delay do we have. But let's say we have like 100-second delay or 100-hour delay. How would we then play back the signal that's given to us? We have to have like a buffer, I would think, that actually remembers the sequence, because what if it has like a 100-hour delay? It has to basically remember 100 worth of signals that's coming in, by essentially. Now what you could do probably is to add like an array that sort of extends depending on, like, each signal that gets put through is put into an array that is then, it's kind of like a queue, I guess. So you would have we have some sort of signal, like let's say, hang on, how do I want to visualize this? Okay, so let's say you get activated, then we push, so this implies that we add it's not first in, first out. It's first, well, it's first in, last out. So you add something to the list, but then you pop from the bottom, right? So you add to list, or some sort of signal, it's either on or off, whatever. You add it to the list, then after, but how would we know when to? So you probably want like a timestamp. I mean, yeah, you want a timestamp. So we want to add like the timestamp and the state, like on or off, to the list, right? And so when then we do an update, we will look at first item. Is the time up? Then run the state. So the time would be like timestamp plus delay. Okay. Run state and remove the item. Right? Isn't that just what you need? And then depending on how, you know, how much time it's gonna build up, or like it's gonna, and how many signals, this array might build up like a lot, but we probably won't have, you know, it's not probably not gonna be that much, you know, to be an issue. But I think that's probably what we need here. So let's have a, I guess it's like kind of like a queue. And let's just use an array list of delay signal, which we will create here, delay signal. So we need signal at or something, which is a timestamp, and then we need the type of signal, which I'm gonna just say it's like a delay state here. It's on or off. We should really make the signal a sort of common concept, because right now it's kind of like we don't really have a concept of signals really. We just have like devices that can be activated and deactivated, and then it kind of like, depending on the type of device, it does a whole bunch of different things. But we don't really have a common concept of signals, but it's starting to emerge here. But this should suffice for now. Okay, so we have like the current state, and then we have the queue. Right. Yeah. And let's make a function here that is, well, okay, let's see what do we need. Where's, yeah, we don't there's no like update function in these things. I should really change these things to use, oh wait, there is an update, I was lying. But I will want to change these things to have like a proper sort of state machine, as I do with the monsters have a state machine, and the boss thing also. I would like more things to have the state machines type things. But let's, I'm not gonna do that this time maybe, but okay. But anyway, let's use this one here. So this one is not gonna get hit by the lens beam, I don't think, to activate. What we want to do is we want to, so basically we don't change the state until the first, so we're looking at the first item. If well, let's say, so we need to look at the first item of the queue. If has has expired item in queue. Let's just call it this, and then we get this item here. Okay, and that would be a delay state. Okay, so that means that we are gonna set ourselves to that state. So self state is equal to item dot state. Okay, and then we're gonna I guess this could be like popping as well if we get it, maybe. Pop expired item in queue, maybe, I don't know. Something like that. Is that gonna be enough? Then we also have to have a way of adding the item, but that's gonna happen in our activate and deactivate. So here's the crucial point. We don't set our own state at this point, and we don't really have that. And if we're on, it doesn't really matter what our state is. We still wanna sort of handle this thing. So this is basically just add item to queue, and it's gonna be on, and then we have to give the timestamp there, right? So now we just need those functions. So we need add item to queue first, and it's gonna be some sort of delay state and a T. And so we have the queue, and we're gonna append. Oh yeah, we need like an allocator as well. Unless we have like a maximum, we assume capacity, we have like a maximum amount. Nah. Let's see. And then what do we add? We add a delay state, so we have state, and then signal at. It's gonna be T plus the delay. Oh no, we don't have T on deactivate. That's bad. Okay, well, we'll have to add it. Okay. No, we don't need an allocator for that. Oh, we need T though. Yeah. We need T in here. Actually, you know what? Let's just change this to pop expired, because if the expired doesn't exist, they should just return false. So then we just get this, yeah. I was just, yeah. That should be fine. Yeah, now you need allocator as well, which we don't have in these things. So should we add that or just add the registry? Probably. Actually, no. What we do is... No. Okay. Actually, you know what? Now this is okay. The way I've done this is a bit weird. It's like we have this activate and deactivate function. Their purpose was to basically just change just this delay device state here before. Now it's a bit more complicated. And then we had this like handle state change function, which gets called whenever the state is changed. Just because I had that pattern going for other things, so I added it here as well. And then we're checking, okay, if is the state changed to on. Here we have a whole bunch of stuff that we can use. But now the problem is we don't really want to change the state to on directly. We want to wait until we're over here, and what we want to do in activate and deactivate is add things to the queue, but that requires us to add more things to the thing. Maybe okay, maybe we do want to add like a state machine now instead, because this is a bit more interesting here. So okay, well, it's not gonna be like init device then. Man, I kind of painted myself into a corner here with this thing. I think it's time to make this into a state machine actually, because this is starting to become more and more complicated where it doesn't have to be. Let's just do that. So let's do a delay device state machine. Okay. And we're gonna have a initial state. And we are going to well, basically I want to set the state to I guess off at the start. But I don't really want to run the functions for that. It's basically gonna be off.update. So the idea is here, we have this doesn't need to be public by the way, but we have off and on states. They're gonna have a pre-function which is run at the transition into the off state. And this one is gonna say, well, this is gonna add a thing to the queue, just like we did with deactivate. So first, we're gonna have a helper function called get device. Okay. So get device and add item to queue, and the state is off, T is this. So now basically, now also we could change this actually to take the context instead to make it more simple. We don't need to put these guys there. This would be create timer instead now. so much more convenience also using this with the delay there. And getting the allocator. There we go. Okay. And then we have an update function. Now, I think the update function is basically is going to be like a common update function. Which will do the thing we're doing here, basically. Let's also add this one, pop expired. And this will be a nullable delay signal. Okay. Right. So we want to check on only the first item in the list. So first we want to check, do we actually have items? So we want to check items.length is 0. Then we return null. Then we get the item, the first item, and we're looking at if item signal at, well, if timer is up, item dot signal at, then we return, well, then we return the item. Okay, is this copyable, by the way? Yes. We just return the item, but we also do, yeah, we also modify the queue as well. So we do swap, no, not swap remove. It has to be ordered remove because it's a queue. And yeah, we just remove the first one, which is like the worst case scenario for this, but I mean, we could also do insert. No, that's also bad. It's gonna be bad whatever, however you do it, I think. Unless you do like a linked list or something. Whatever. It's probably not gonna be, you know, that much of a deal. So actually we could just return this, I think. This returns the item. Yeah. Okay, but if we don't, if it's not up, then we return null. The timer is not expired. I should really change this to is timer expired. I can't be asked to do it right now, or maybe I can actually. It's just a case of doing this, and then there's a lot of files using that, but that went pretty well. Okay, now here we do this. Yeah. Okay. It's so much easier just reasoning about the state machine. Well, it's we'll see what the result will be here. Activate, deactivate. We basically won't really have these functions anymore because this is not going to be a typical Let's do this. Because otherwise they will be in the diagnostics. Expected type, state machine context found. Yeah, so we don't do anything here either. Let's just remove this for now, because I need to figure out how to actually make this work with the delay, or I mean the device system as well. Okay. So, yeah, that's basically that's the common behavior. So we may not even have a state anymore, actually, but well, actually this would be, we would actually, no, yeah, wait. Okay, this is kind of weird. No, it still needs to be a sort of device, because what we're doing is we're actually having the activate and deactivate. They still need to be working, man, because other the whole point is that other devices will call these functions, will call activate and deactivate, which will sort of change the state of this. But the whole problem here is that we don't have access to things, more things that we need here. But it could be maybe like a special case just for this one. Yeah, so here, this one is the device type, which is kind of like, yeah, it's gonna be any of these. It's kind of like a common interface, you could say, for all devices. And so the idea is that you could, if you have any device type, which is any of these types, it's a union enum here, you could call activate on any of them, which then goes in here, it grabs the state, or it grabs the inner sort of type and calls activate on that. So that's the whole idea here. So how would that work with the state machines then? Because you don't no longer have like this common interface unless we keep it, but now we need more information here. Now we need more things here. I mean, I guess maybe the end result is just add more things here actually. Really, what we're missing is a T in deactivate. I think I'm just gonna add that. Yeah, I'm just gonna add the T because that will make this work here. I think. That's the thing we're missing here. All right, so that should trigger a whole bunch of errors. Luckily, we have T available. pretty much everywhere. Okay. Alright, now it's this one. So this one is basically just because all of the previous deactivate functions do not support T. So I'm just gonna then add it here. Because what I'm thinking is for the delay, I'm gonna use that to say to change some state on the device, on the like the main struct, and then I'm gonna look at that in the update function of the state machine. And that is in turn gonna see, we got a signal coming in. We got a signals update. And we're gonna then record that. Yeah. It's just mentally taxing to do a thing like that when you're not, fully engrossed in the system yet, because there was a long time ago since I went into and did stuff here, and it's kind of like a heavy sort of, I don't know, system where a lot of things is happening. So when you change stuff like this, you don't really, or when you change anything in it, you need to make sure that you're not breaking anything. And so it's just like, I was just having to go through a bunch of ideas before landing on this one, because it's, yeah. And what we're gonna do here is, I think, instead of adding to the queue here, we are actually going to save this timestamp, because this is basically what's gonna happen. Is this is gonna happen one frame. The device system. Actually, let me look at the game update function here. So we have the device system is happening up here. So that will trigger sort of the activate things. Then we have the state machine down here. So we will have the state of the devices available to us there. Okay, so that is good. Because whatever this thing is doing from the device point of view is gonna get picked up by the state machine. So I'm gonna add a timestamp here, activated at, or state changed. So I want a delay signal. This is like the latest signal. I'm gonna call this like signal in or something, because you're not gonna get, I don't think we're gonna get, like, if we get multiple signals in one frame, I think that's gonna be like a bug or a mistake in designing the level or something. I'm just gonna have support for one signal in. It doesn't really make sense to have more right now. And that's gonna get set whenever we, and that's gonna be a nullable. We set this to null. So in the update function, we will look at this and see, okay, is it null? Then we don't do anything. Is it populated? Then we will push that signal into the queue. Okay. Now for activate and deactivate, we will simply set this signal in. And we will set this to on, and we'll set signal at is equal to t plus delay get. And then signal, no, not signal out, Signal in is the same thing except it's off. Okay. So that will get set there. Then the update function. Here the common behavior. This guy will look at if device has a signal in, then we will add that to the queue. Okay, I guess we don't even need T at this point because it's happening in the same frame. Oh, okay, my bad. But I guess it's good to have like T and deactivate anyway. Okay, whatever. I guess we didn't really need to add that. So actually, then this is just a delay state instead. And we simply set that there, and we don't even need T. Great. Okay, well, it kind of worked out anyway. All right. Just fixing the afterglow of changing that. Okay. So, yeah, we're gonna have like an off state, on state, and this common behavior. So whenever we get a signal in, we will add this item to the queue. Oh yeah, and now we also need to clear the signal as well. There we go, so we don't add it multiple times. Hello. Well, if I pronounce your name in Swedish, it's actually gonna be a bit different, but I don't think it's that. I'm not sure how to pronounce it actually. Ropet Patinsin. Welcome. Zig feels wow, man. Cool. Have you tried it? Hello, hello. It is actually, I think it's extremely fun language. Please pronounce it in Swedish. Okay, well, the first name, Ropet, is like, it means like, in Swedish it means the scream or or the call or something like that. Like you're calling, you're shouting, the shout. Okay, yeah, the shout, it means the shout or the scream. C++ fun. I don't know if that is, if you can equate C++ with fun. No, I'm just kidding. I haven't actually, like I haven't used C++ in like, well, how long ago did I program in C++? I think it was like 15 years ago or something. So I don't know about that, but I think SIG is fun for me because it's like a new language that has like new sort of ideas, and I also I think programming is fun in general. So yeah. Like, are you sarcastic when you say C++ fun? Or do you actually think it's fun? I'm gonna guess you're sarcastic. I don't know. I mean, I don't want to insult people that actually think it's fun, but you know, I think programming in general is fun, and but SIG feels like a new breath of fresh air, and Oh, you heard it's fun? Oh, okay. Compared to Rust. Okay. Are you a developer? Let's see. I haven't tried Rust, but well, actually, I lied. I have tried Rust, and it didn't go so well because I didn't like learn anything about the language, and I just tried it, but nothing that I did. The compiler was like unhappy with everything that I did, so my, you know, prior teachings didn't work in Rust, and so yeah, I realized I had to sort of read up on how it works first and then try it, but I never did it. So I don't actually have the desire to learn Rust because I kind of know about it already, and I know that the trait system is nice, but it's also like a worse version of the Haskell type classes. And then I would just think, okay, but then I can just I could just use Haskell instead. But Haskell has its own problems as well. But you having fun and debug several months? Yeah, that is kind of you have to be very careful when you're dealing with like low level manual memory management. Because the problems is that you can get these weird error messages like seg fault. Okay, then okay, there's something wrong with some pointer somewhere, but it really it can get hard to actually find where you're supposed to fix the error if you get those kind of errors, at least in Zig. Also, you're a hobbyist. Okay. Well, I was self-taught when I first started, and I would say I learned more by myself than I did in school. But in school, I actually learned like you learn a lot of common things, or like I guess you would learn like more. Well, at least in the school that I went to, we like computer science university. We learn like I don't know, operating system, process, like running, whatever it was, like round robin process running, things that are very important. No, but it's interesting if you're interested in that kind of stuff. You learn like, but we had like a thing where you learned like a lot of different languages, but you just dipped your toes a little bit. So it was a kind of a really broad thing, but you didn't really go on like that deep in any language. So I didn't feel like I learned that much actual programming, that is. Anyway, but then when you start to work in it, that's when you actually start to learn a lot more, because then you have to sort of solve a bunch of issues that you may not have solved. I mean, depending on your sort of motivation or whatever when you're self-taught. I just think building something and then seeing it actually work, it was like a dopamine fix. Let's see. Yeah, so update, we look at the signal, we add it to the queue, we clear it, and then we see, do we have any expired items in the queue? In that case, what we want to do then, we want to set our state. So here we actually don't want to do this. We probably want to do something else here, but now we have the signal in for that. So this will actually, I think we're gonna set our state to whatever state is in here. Set state, and and we have like a delay state. Oops. We need a convenience function for this. I'm just gonna switch on the state. If it's on, we will set this state to on. If it's off, we're gonna set this to off. There we go. Because now we can call this set state instead, depending on this one. There we go. And that could sort of trigger things like, I don't know, setting animations, doing whatever. And let's add on state as well. Okay, now we have sort of the basic structure there. I like how huge your font is. Very appreciated. It's rare. Yeah, I did get, like, early on, I did get complaints about the font size from like a test. My brother who looked at the stream, and okay, well, I just decided, okay, well, I'll you know, it's good for me as well. My site is not what it used to be. And now I'm kind of used to it. It's also nice because the sort of I'm also treating like this whole window as the limit to how many characters I'm gonna have in one line as well. So it works. It's sometimes it's, you know, I would like to see more things on the screen. However, I think it's also good because if you have less characters on the screen, you're kind of also inclined to, if you have big, you know, like bulky functions and it looks a lot on the screen, then you're kind of inclined to sort of well, break those out into smaller pieces. So it actually helps out with that as well, I would say. So I think it's actually kind of nice to program like this. I wouldn't do it maybe if I didn't need to, but I don't mind it. All right. So what more do we need to have? I think here we need to sort of set animations and stuff. And so what language are you learning, Rupert? Rupert. What language is that, by the way? Or what country are you from? Or is it your real name? I guess I should ask as well. I'm guessing yes, but I just want to make sure. Maybe it's just, you know, made up or something. I don't know. Let's see. Okay, so what's gonna happen here? We also have this thing where whenever we are activated, we should activate other things. So I should also change this as well. I should move this to the state machine just to have everything like in the same place. Now the bad thing about that is I cannot change the order of updates in the main game. So basically, instead of that function being run up here, it's actually going to be run down here. But I'm not sure if that's going to be. That's probably not going to be a huge issue. We do things here. We do update device, which calls the update function, and then we do handle state changed. And this one will, well, this thing will just set that thing. That's fine. That's like, this doesn't really do anything basically. We're updating animation. So this is kind of like a generic update animation functionality for all devices, which basically we have a function on all devices called get animation, which should get the current animation based on the state, which is like usually on or off. Or if it's a door, you also have like opening and closing. And then we have also if it's looping or not. And then we start it. So that's what's happening here. I'm basically gonna see if like I should probably like, you know, mimic this, and then we just call this. So I don't think there's gonna be a huge issue just changing that actually. So I think, yeah, we'll probably I'll move this functionality here. So what I will do is I will comment this out, and for on we're gonna do this. Let's start there actually. So when on is set, now this happens in here instead. Okay. And we will go through all of our activities and activate them. And we also have the context here that we can use to get these things. Yeah, and that should be fine. And yeah, now we don't have to have, I mean, I'm tempted to go through every device now and do the same thing. Because it's just so much, it's so much nicer, this kind of system. I should have done this from the start, but I didn't really think about what I needed at that point. But anyway, water under the bridge or whatever they say. Let's see, so here we do the same thing except we do like deactivate instead. Okay. We also need this. Okay, now the only thing left is basically setting the animation as well. So I think we have like, I mean, there's set animation. There's also like monster util set animation, which is kind of weird now because this is more like state machine utils actually. Set animation, but because this is kind of doesn't really care if it's a monster or not. So, but I will use that. So set animation, because now we're using like the state machine context as a, you know, kind of like a monad. Oh, thanks for the follow, Ropet. Let's see, animation key. Oh yeah, so this would just be like on. And then we have some options, and we can say it's gonna loop, and it's gonna start. Yes, both of those are true, so we don't need to change anything. There we go. And here we also set animation to off. All right. Sorry, I was asking where are you from? Because I'm curious about your name, because I wonder what language that is. Yes. Let's see, do we need to do anything when it's transitioning away? I don't think so. It's a fake name. Oh, I was actually asking that as well, if it was fake, but I wasn't sure if I was like British. Okay. Yeah, because I was thinking, wait, is that like Italian or something? But then I was like, no, it doesn't seem familiar, or or I don't recognize. Although I don't know that much about Italy though, but you know, I've seen names, whatever. But device machine. Okay, so is this enough now? What do we need to do? First we set the state to off. I guess now we don't really need to worry about. Well, this should be fine. I think we also need. Oh yeah, one thing that we're actually missing here is handle state changed. This actually has a bool, a flag here, which is activation enabled, which is kind of like we want to run the update. We want to run this handle state change function, but we don't want to activate other entities based on this, because the only thing we want to do is sort of maybe set animations and stuff, but we don't want to sort of run the all. Because it's used when we load in the game, at which point we do want to handle some of the state change functionality, but not like activating other entities, because we already have the correct sort of state for everything, but we do need to set animations and stuff like that. You know Italy? Mussolini? Okay. Yeah, I know. I know that too. Okay. Great. So the question is then, when we do handle state change. Because now when we call activate, actually that's gonna happen later at update. So the question is, no, it's calling. I think it's calling set state actually, and then handle state change. Yeah. Also, yeah, we need the state as well. We need to do that. We need to say set state, or let's just change it directly. This is gonna be on. Up here, over here is gonna be off. Okay, because it's used also when we save the game. When we save the game. Well, okay. For delayed device, I'm not sure if we actually need to. Yeah, we're gonna treat delayed devices as being, as you know, not savable. Basically, they're always gonna be sort of cleared, I think. So for this case, we don't really need to set the state, but for other devices, we do need to sort of have the same kind of interface where we have a state. It's gonna be looked at. It's gonna get saved in the save thing. So we should keep that pattern going. But what I was thinking about was maybe have something here that will what do we want to do? Wait, what was I thinking about actually? Yeah, the thing is we don't want to run this. Well, we do want to run it at the start, I guess. The thing is, or I mean, not at the start, but during the game, the state machine is going to be the thing that's updated during the game. during the startup, during the load file, we're not actually running this. What we're doing is we're running this, like set state, and then we run handle state change. So what I was thinking is maybe we just set the state. Yeah. It's complicated now because we basically have two systems working together instead of one all of a sudden. Okay. Like, I wish I could solve this only with the state machine. I'm trying to go that way. What do we need to do here? It's basically only for the first initial thing, which means we don't want to. Yeah, okay, so we don't want to do these things, but we do want to set like animation stuff. So maybe we can have like a startup state. Well, we do have a startup state. It's like this one. But then this specific delay device is always going to be off, so it doesn't really matter, actually. Yeah, because we're not going to load in and be on. So it should always be off. But we don't want to set these things. We don't want to do that. We just want to do this. Okay. So I'm gonna say well, we could just do this. We can just say this. You could also break this out into a function, which is like off pre common or something. It's like common off pre or off pre without activation, you know, of other things. Oops. There we go. And now we can use that over here. Right. So if we wanna like play a sound or something like that, we can also add it there. Well, I guess maybe we don't want to play a sound in the initial thing, actually. Okay, well, whatever. Yeah, so that should be good. We could also just set the state to common behavior here, but No, this should be fine. All right. So I think that's probably what we need to do here, if I remember everything correctly here. And so, well, we do have the animation stuff. I think we're just gonna remove these. Yeah, actually, when we're the off animation actually is not looping. It doesn't really matter since it's just one frame, I guess, but whatever. Yeah, because I'm pretty sure looping is like true. I guess it doesn't hurt to sort of explicitly define it. Yeah, and then we have like common stuff as well, like hitbox, activate, deactivate, handle state change. So I think we do sort of need this function. Well, I'm gonna remove it actually, and the update function. And then what we're gonna do is we're gonna go to wherever we get some errors. We should get errors saying there's no function named update. Or maybe not. Oh, we're actually, so this is kind of cool actually as well, because this kind of mimics like an override feature where you're checking first, like this happens in comp time. We're checking on the type. Do we have an update function? In that case, we call it. So in the runtime code, this if doesn't really exist. It just calls the function. But if the update function is not, it does not exist, then basically just optimize that away, so we don't actually, yeah, we don't do anything here basically. So that's nice. It's kind of, yeah, because then it's kind of like an override. You're going through all the types, or yeah, you're based on what type you put in. We are checking. It's kind of like a virtual table as well, because you're checking through the tag which type or function you're supposed to call, and it selects that if it exists. If it doesn't exist, then it doesn't do anything. All right, so yes, can we now? Well, it's compiling, I guess. It should be working. Is it? No. So if everything now works correctly, we should be able to go to that room, that puzzle, and see if it works. So the game runs at least, but that's not the real test here. Here's the room. So this puzzle here, I went through this at the start here, but basically this is like an upgrade room. You go in, you enter from down here, and then this door is open from the start, and then you get over to this area activator here. This is connected to the door, so the door closes when you collide with this thing, and that is connected to this one, which activates this, which then is connected to all of this. So we have like a puzzle here where these ones are solid, and then they're not solid if you activate them or deactivate them. And so the idea is that these two platforms are going to be solid at the same time, and then this one is going to be not solid, and so you're going to have to like jump here and time the jump, up there. These ones, this guy is connected to these two, which now these are the new thing that we're doing here. This is the delay signal device. So this one's connected to this guy, which is connected to this one, which is delayed. So this one has the same signal as these ones. So but it's delayed. So they're gonna be on, that's gonna be off, that's gonna be on, they're gonna be off. And then also to keep the system going, we have another delay up here, which is like a full cycle delay, which then activates back, sends the, it's like a feedback loop back into this one. So now we have like a full feedback loop, and it's gonna be interesting to see if this actually works. Whoops. Oh. Bad path name, okay. Well, that didn't work. Bad path name. Okay. Let's look at that. And we also get like 1,000,000 leaks for some reason. Oh yeah, drag entity state. Okay, I'm not gonna worry about that for now, but bad path name. Is it because we're running from Linux or something? Like if we, yeah, that might be the case. Let's see here. Where is this happening? Here, no? Okay, starting. Actually, I can just use reference now. Context. Okay. So we're getting the path. It doesn't. Why is the path like relative? Find path. Oh, I see. It's like the okay. It's not the same thing. So this is like an defer. Okay. I was like thinking this is where the call happens, but I didn't look at this. So we got an defer. This is basically in this scope we catch any error. If we get an error, then we, you know, display this message here. But where's the error actually happening? It's like bad path name. So I mean, it's maybe here. This is okay. This is kind of where this pattern is bad, because now I don't know where the error is happening. But well, it's bad, I guess, in this case, I should say. So it shouldn't be alloc print. That doesn't really throw that kind of error. It could be down here at real path alloc. I don't think so though. It could be at spawn and wait, which is in process child thing. spawn error. Maybe not, actually. Okay. So maybe it is real path, actually, that is gonna be weird. The difference that... okay. So I should explain, like before, I was running... Because, okay, my setup is like this. I have WSL. I'm running on my real operating system is Windows. That's the base operating system. Then I'm running WSL, which is Linux running in Windows on like a virtual machine, which is like an official sort of Windows thing that you can do. And then there's like two, but they are kind of interoperating as well. So you can run Windows. You can run Windows like programs from Linux, and then you can also run Linux well, maybe you can't actually, but you can run Linux programs in Linux, of course. And the problem is like the paths, because if you're on the Windows machine, that's gonna interpret paths as Windows paths. If you're on the Linux machine, you have to format them as Linux paths. But then there's also two different file systems. So you have the Linux file system and the Windows file system. Now, it seems like, well, the Linux file system does have access to the Windows file system, so that works perfectly. However, the Windows has like, it seems like limited access to the Linux file system. It works somewhat sometimes, and the difference now is that I'm running the game editor here, or my program is running from the Linux file system instead of the Windows file system, because of the reason because I wanted the LSP to work and also the compiler to run more faster, because it doesn't support Windows yet with a new compiler for Zig in 0.15.1. So there's a bunch of different reasons why this is happening here. And now there's a problem with the paths. So I'm not sure actually how to fix this, unless we just run it on the Windows file system again, but then the LSP won't work, and yeah, it's gonna be very sad. I guess what we could do is run like in an installer, like in the script we will sort of install the program in a Windows location instead. That could work. Okay, we can do, let's do a script. Let's do like run. Okay. So we want to do this, right? But we just want to do build. And then we know that we have like a sig out bin. So here you can see the results. Now, do I want to copy these things? I just want to copy, I guess, the PDB. I don't know if I need that, but I guess we can select a site on the Windows machine. We just copy the exe over there. Do I need anything else? I think I need like the layout. Okay, we'll do this. I will make actually, let's do no. Sig game editor. No, let's do it here. Let's do like yeah, Sig game editor from Linux. Okay, and then I'm just gonna copy over this. No, that's not needed. I don't think that's not gonna be like a. Is that? No, that's not needed. But I'm gonna copy this so I don't have to sort of change the size of everything again. I'm gonna copy over maybe session. No, I don't think I need the session. Is there anything else that I need in here? I don't think so. Okay. Maybe assets. Yeah, okay. I do need assets. It's just one thing anyway, so I'll just copy that. Maybe you can link it. No, let's not do that. It's a directory. Okay, I'm just gonna do this. Make their assets, copy assets into that. There we go. All right, now we have assets, we have imgui. Okay. Right, so now what we need to do, I guess I could, I could do that in the script as well. But let's do, so we build it, then we want to copy zig out bin, and what was it called? Sig game editor. To this place. And I want to copy also the PDB just in case I need it. There we go. And then we are going to run that. And I'm probably, yeah, I need to, well, actually, I need to change the directory and then run it. Okay. Now this guy, I will say instead run.sh, and we need to make it executable. There we go. Okay, let's try that. Whoops, I need to source my session. No, failure. Okay, cannot create. No, I missed the thing. Dev. Command not found. Okay, let's see what's in here now. I have a whole bunch of these. So it is there. command not found. Do I have to say like this? Okay, apparently. Well, that seems to work. Let me resize the window. I will open up the project. There we go. Let's go back to this room and try to start the game. Okay, it seems to work. It's just compiling the game. Okay, nice. Got it working here. All right, so this is the thing we're looking at here. So this should be, yeah, you can see it's not really working here. Oh, there we go. Okay. It turned on and off once, and then and this one doesn't really. So I'm gonna go out on a limb here and say the delay function, or the delay thing, doesn't actually work. What the hell? What the fuck? What does this come from here? Okay, interesting. Gonna keep an eye on that. Okay, but this seems to work, so nice. Why is the delay thing not working though? Okay, let's do some. Oh! I just realized something. I just realized that we don't add a state machine component here. So we need to grab the entity and we need to add a state machine, and the initial state machine is delayed by state machine dot initial. There we go. Okay. And now we're actually running this code in here, so we get some more errors. Okay, set state, you need context, and that was it. I'm just gonna compile, see if it runs. Still using LLVM somehow in here. Okay. Yeah, let's just run it and see. Okay. No? Still. Okay, you know what? Let's move these guys over here so we can see them. Okay. Oh. They are not even spawned. That might have something to do with it. I don't know. Okay. Let's check for errors here. Or could not something delay. Did not find entity type tag for delay device. Okay. Nice FPS. Yeah. The FPS is why isn't it finding it? It's there for like reference. If I see that it like dips below a certain FPS, I will start to think about like optimizing, but I don't. Maybe it's like distracting. I don't really need it until, you know, we need to do stuff at the maybe like at the polish stage or something. I don't know. This is my basically first game, you could say, like first, I guess first project that I'm trying to make, like, I don't know. Okay, let's put it like this. This is my first game project that has gone this far. I'm not an experienced game developer. This is like, I have never released a game, so I'm learning. Limited to 300. No, it's not limited. I've had like, I think when you just run the Raylib update function, it goes up to like 1500 FPS on my machine. So when you're not doing anything, basically, you're just clearing the background or whatever, it has like 1400 FPS. Why is this not spawning in? However, if we run, I can actually run this game in Linux, and you can see if I can actually. Maybe I can't right now. Well, I guess we can try. No, there's a pathing error there. Yeah. Anyway, but if I run it on Linux on the WSL, it's actually gonna run at like 20 FPS or something. So there is optimization to be done, and I believe the bottleneck is like the collision detection system, which is using a quad tree right now, but I think I can optimize it a little bit to to fix that. Basically, one thing that I think we could do is, because we're rebuilding the quad tree every frame, I'm not sure if that's the bottleneck though, but every sort of tile in the game is, well, not every tile, but every tile is sort of merged into a larger square or a larger rectangle, and those are static. Like the ground and walls and stuff, those are like static, so they don't ever move. So you could utilize that and maybe have like a base quad tree or something where all the static things are in, and then you just add dynamic stuff. I don't know. We'll see. Another win for Windows. Well, it's not really fair because I'm running Linux on a virtual machine in Windows. So I think that's more the why it's slow, not just because it's Linux, you know. So yeah, it's not really a fair comparison, but it's because of my setup that it's so much slower. But it is kind of a nice way of looking at it. Okay, if I can get that version to be so optimized that I can run it with no problem on like 60 FPS, then it's gonna be good. I don't know. Linux is still virtual thing. I mean, if you run Linux as a real operating system, like as your base actual operating system, then it's just like Windows. Except it's Linux instead. But the way I've set it up here is I'm running Linux in a virtual machine, which is not the case if you're installing Linux on your computer as your main operating system. But why is that not being done? Is there a typo here? Delay device. Okay. Did it not find entity type tag? Did not. So it's not finding it here. It says. But it is right here. Entity type name. Okay. This guy is a delay device. Oh no. Okay, we get another issue. Okay, yeah. So actually, okay, so we did the whole copy the game editor out into the Windows file system. We also have to do for the game, because I think that this is running like another. Okay. Actually, okay. Let's do. Yeah. It's a problem with the. Well, we don't have environment here. We have. Where is that Kottefolket? Yeah, we have this one. This is the problem here. We're trying to spawn this one, but this is wrong now because we changed the path. So we have to make. I'm just gonna do it like an absolute thing. I'm just gonna say this is. No, this is in Windows. Dev. No, it's Linux. How do we do that? I'm kidding. Okay, sorry. I was kind of like, are you joking or not? But you know, you never know with those things. You never know how much people know and when they're joking, or it's hard to. I don't know. Sorry. What do I? So how do we do this? Do I just hard code this path here? What is the path? What is the path in Windows? I have to sort of look this up. Could we do something like this? Okay. Will this work? Why is Windows using this? I'm gonna try this instead. This is one of the banes of like paths. Okay, let's try this. Also, really fast compilation times now. There we go. No, we don't. Actually, there we don't go. It still didn't. Wait, what's this? Oh, it still ran the thing. It still ran the thing. Okay, so we're not checking for errors. Right. Let's see. It still ran like the old thing. So if I think it's like if this is not running, or if then exit 1. Okay, I have to look this up. It's always the case with bash scripts. Always have to look up what the syntax is. I can never remember the syntax of this because it's just, yeah. Bash script if statement. Okay, let me do this. I don't know. How is that different? To me, this doesn't make any sense. But okay, whatever. Can you do like, I'm pretty sure you can do like a one-liner. If in one line. Oh, so you don't have like, okay. So you don't have a semicolon after then. Okay. There we go. So if that goes wrong, we quit. We should have that on everything here. Basically. Okay. Expected assessment, yes. So now we do this. And I was just praising like compilation time when it just bypassed the whole compilation and ran the old version. All right, let's see now if this works. Okay, there we go. We got some other errors here. Seg fault. What? No zig. Build zig file. Oh, what's happening here? CMD. Oh no. Ooh. Okay, CMD. Yeah, CMD does not support defaulting to Windows directory. That feels, you know, that feels like it a security issue here. Initialize build zig, template zig init. Yeah, there's an error, no thing found, and then it's like doing something here. Seg fault. How do we get a seg fault here and play inner? Oh, because we're freeing this. Right, so we don't want to do that. There we go. Okay. What now? Okay, wait, what was the issue? Oh yeah, cmd.exist. Okay, so spawn and wait. Here's the problem here. We're trying to run a Windows command. I think what we want to do is just run I mean, we don't even need CMD here because we're in Windows already. So okay, so actually, okay, I'm gonna do this, and then I'm gonna say command. Like, why did I even do that? I think it's because I was thinking I'm running from Linux, but I'm actually not, because now we're running the program. The program is running in Windows, so we don't need to call cmd.exe. We just need to call zig build run seam, and then that. Well, it crashed. Okay. Oh, ZGE build path name, bad path name. How's that a bad path name? It's because of this slash here. But this is from the build. This is from the build system, right? Okay, we'll do it like this. We don't call build. Actually, what we do is we will just call. Well, okay, that's the current working directory. The command. Can you select? Like, how does this work? Can you actually... Can you do this? I don't know if you can. But I guess we can try. So I'm gonna make sure that the game is compiled. And then we will run it. Okay, it crashes. Okay, here we go. It works. Nice. Call and get animation without implementation. Right. Why was that not a thing? An error here. Oh, because we're still like calling it. I see. Okay. So if we have it, we call it. Otherwise, we have an error. I think it's because, I mean, this is kind of stupid because we don't really need to do this. Like, if we actually want to this to be an error, what we should do is say, I mean, we could just remove has declaration altogether, or we could make like we could have like a compiler error instead. Instead of having this as a runtime error, we can catch it in compile time and say blah 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 needs to implement get animation looping or whatever. This is actually like function name. Something like this, where this is like type name of type of S instead of doing that, oops. So now this is a compiler error, and we should get to it. So the delay device needs to implement get animation looping, right? So now we get that as a compiler error. If you want that to be a compiler error, like I don't think I want that to be a compiler error, so I will just say I would just, you know, return true, because that's like the default. Okay, and then for animation, now this is a bit different actually. I think this needs to be like a nullable. Or yeah, return null and optional, I mean. And this is called over here. Now, I would say animation key is equal to self get animation. Now this is optional, so if this doesn't exist, I think we just return. Okay. Right. Same thing here. If we don't have an animation, we should not do all of this. So this kind of stupid here, because now we have to sort of do this twice. Like, this is one thing about this pattern that I don't really like, because if you have multiple sort of optionals that you want to have, you have to nest the ifs. And I'm not sure about any pattern that goes around this. If it's like the only thing that I can think about is making this into a function, and then instead of having these nested ifs, you would say animation container instance equal to maybe this or else return. And we can't do that now because we have other stuff that we want to run down here. But then you could have this in a function, and then like initial animation is equal to device type get animation or else return. So now if we have this, we can remove this nested thing, and we can do that. So that's how you could do that, but then you have to move that into a separate function. I'm not gonna do that right now. But that's the only way to sort of solve this. There's no way of solving this if you're in another function like this, as far as I know. But anyway. Do we have any more compiler errors? No. Let's try this again. Another crash. Another day, another crash. Call and get animation without... Oh, yeah. So now I have to make sure to actually compile. Actually, I need to compile for Windows, not for Linux. Okay. So let's add... I guess... Wait, do I have like... F7? I do have F8. Okay. F7 is gonna be the target x86 64 Windows. There we go. So we source that F7. Takes a little longer. There we go, because it's on Windows. And now we can hopefully run this with the updated thing. But it still doesn't run it, and I think it also crashed. no errors. Or, well, we should have errors. Already added to group devices. Okay. Reach unreachable code. Interesting. Entity. It feels like we're adding something multiple times, maybe. State machine. Oops. 106. No, 107. We're getting something. Okay, delay 30. We're getting the delay device. Oh yeah, we haven't added it. My bad. We'll add it here. Delay device. There we go. I mean, I guess we do have device type. So we don't really, okay. Yeah, that's the wrong thing. We actually get device should actually return. We should actually get this. No, device type, which is on C, and then we get delay, and we return the pointer to that. There we go. Okay. Well, at least it didn't exist. Oh, now this one is messing up. Why? What happened? There was a leak. Maybe it just lagged a little bit. Yeah, the leak sometimes makes it lag. I don't know. But why did... So the delay device. Okay, apparently. Oh, okay. I know what happened. What's happening? So they do still exist, I believe. Yeah, it was the thing that I added where the animation thing did not. Wait, maybe I should just add that function. Now where are we? Device. Yeah, this part. Like we don't have an animation. It's just that I want to move this functionality to the state machine instead. Okay, you know what? I'm just gonna copy this and move it into here. So this is mission container delay device. You are added there. I'm just gonna say no here then. Where is this coming from? Update the animation. We don't really need to do that. I think we're just... say this. Yeah, we need initial animation. That's gonna be like off. It doesn't really matter because the state machine is gonna handle that. Okay. We will compile. Success. Okay, great. There we go. Now we can see them. And they are both off. Okay. So I will move over here. That will... Okay. There you can see the delay sort of works. Now this one is on. Oh wow, it actually works. Okay. Interesting. Oh, I think I put that too far there. Yeah. Okay, so it actually works. Wow, I wasn't expecting that. But there's something going on when I quit. I think it's the leak stuff. Yeah. I need to fix that as well. Okay, but that works. All right, so now we just need to fix the level here. So I'll move you guys out here now. Move this so it's not like visible. I think these guys are like one tile too high. And then we need to move you down. So now we can jump like that. And I think we need to change this guy as well. Oops. Like that. Okay, let's try this now. Oh, but now that is not activated. Okay, yeah, but it's because this is kind of like now it's saved a bunch of states here. We should really, yeah, this should be like reset. Let's go to save, and I will reset everything here. Toggle time toggle delay device, just delay. What else do we have? We have extend something, block C. All right. Okay. So now it's kind of initiated there. Wait, what's going on now? That one... Okay, so at the start, this one is not activated. Will I fall through? Okay, good. Although it looks weird, I think the draw layer should maybe change. Interesting. Should the draw layer change based on like the state? I mean, it is, I think it is possible to do. We can go to the delay machine thing and when we are turned on, that means, what does that even mean? Wait, no, it's not this one, it's extend block thing. Here we go. So when we are, here we go. If we're solid, we say get draw layer but we don't have those layers. We need to sort of store them globally then, basically. Let's do this. Original draw layer. I'm just gonna, you know, force this in here. So this is, I believe, what was it, U32 or something? Yeah. There. Properties, we also need draw layer. Original draw layer is draw layer. Right, so that's that. Then I think we just changed you to this is the original. Here we're gonna change it to, I guess, -1 or 2. Maybe? Because -1 is gonna be like the player. -2 might be the monster. Yeah, I'm just gonna, you know, it's super ugly, but I just wanna see if it works, how it looks. What's your problem? Expected 2 arguments. Oh yeah, so entity is over here. Oh yeah, we need to start this guy. There we go. Yeah, there we go. Now we're falling through. And we are now in front of those instead of behind. But when they are solid, they are like in front instead. Okay, cool. All right. Now, what about this timing issue here? I think it's because these guys, they should really be like initial value off. Let's see if that's better. Yeah. All right. Cool. Let's see if we can fix this crash here. It takes like forever to close this. What is happening here? Is it just because of the leak? There's like one leak. That can't be the reason. Now what is the leak here? main 98. It's this one. Wait, what's happening here? Oh yeah, so we're setting that. Hang on. What is happening? This is set to this, which could be null. If this is not null, where this is this the initialized args with allocator? So that's allocated, and then we deinitialize that. Okay, so this is kind of weird. I would rather like duplicate this instead in that case, because we need to make sure that this is deinitialized or freed up in that case. Project options enter scene. If we have that, we get the file name. Now this one is stored in asset index, so we don't want to deallocate that in that case. And then we have an error if we don't find it. Okay. But over here, we're joining with an allocator, so now we should deallocate this. This is like a new thing. So I think what we'll do is like absoluted entry scene is a nullable path thing. And then we set u to that. We also set the u to this. And then we defer if we have this, we will free it. There we go. Okay, I will ignore that error. Will this fix this thing is the question. Okay. It's a lot faster now. Let's make this run a little bit, see if it still crashes. There might be something else. Whoa. I have to sort of fix that as well. Like, we have some weird behavior when you're suddenly colliding like that. Like if hang on. Yeah, I don't know. Okay, but that fixed that. Cool. All right. I think I'm out of time here, but yeah, that was a nice session. We got some we got these delay mechanisms working. So these guys. So now we can build more, you know, these kind of puzzles here, and possibly other stuff as well. So yeah, I'm gonna try and figure out what to do with the rest of this room here. It's probably just gonna be, you know, a testing ground for like different puzzles and stuff. But so yeah, I'm not sure exactly how it will look, you know, in the final result or whatever. But yeah, it's nice to. I might also change these to all to use like state machines instead, like these two are doing now, and maybe change the whole device system to work with that instead, and just strip it bare bones to whatever is essential to make it work with like saving and loading state and stuff like that. And then, because that's the only real thing that they need to support basically, and then the rest could be handled by the state machine. So that should be good. All right. But yeah, that's gonna be it for this time. I'm out of time here, but thank you very much for watching and joining me here. So I hope you have a nice day, and I'll see you later. Bye bye.